let's see the topic on polar curves. Before that, let us see what is a polar curve. Polar curve is a polar curve is a graphical representation of light intensity with respect to angular position in horizontal or vertical planes. It means polar curves is a graphical representation which we plot in x and y axis. So it is a measurement of light intensity, representation of a light intensity with respect to the angular position. It may be either in horizontal plane or in vertical planes. So there are two types of polar curves. Two types of polar curves. The first one is horizontal polar curves. What is a horizontal polar curves? If a candle power is measured at angular position in horizontal plane, a horizontal curve is obtained. Okay, horizontal polar curves. It means if a candle power, when candle power is measured with respect to its angular position, horizontal in a horizontal plane, horizontal polar curve is obtained. This graph, this curve is like this horizontally. So the next second type of the polar curve is vertical polar curve. If a candle power is measured at angular position in vertical plane, a vertical curve is obtained. So here in vertical polar curve, if a candle power is measured at angular position in vertical plane, vertical curve is obtained. So this graph comes like this vertically. So by this we can tell that polar curves totally depends upon the intensity of a light, and horizontal or vertical polar curves depends on how we measure. It means if we measure the light intensity in horizontal plane, a horizontal polar curve is obtained, and if we measure the light in vertical plane, a vertical curve is obtained. So let us see the derivation of a polar curves. So for that, so this is a x and y axis. Sorry, x, y. So this is the initial point. So from initial, this is the x axis and this is the y axis. So let us consider here a point P with the coordinates r comma theta. So this x-axis is also called as initial line, and this origin is also called as pole. So when we join O and P, this is called as radius vector O and P. This we denote as R, O and P. So here from P we draw a perpendicular to the initial line. Thus we represent it as Q, and here r comma theta are the coordinates of the point P. And then theta is the angle between the initial line and the radius vector. So now let us derive how the equation comes. So here, as we have said, x is equals to r cos theta and y equals to r sin theta. So taking square on both the sides and adding them, x square plus y square equals to r square cos square theta plus r square sin square theta. X square plus y square equals to r square cos square theta plus sin square theta. X square plus y square equals to r square. So we all know cos square theta plus sin square theta is equals to 1. X square plus y square equals to r square. So this I'll write it as r square equals to x square plus y square. R equals to under root of x square plus y square. So we use this equation while converting the given equation from Cartesian curve to polar curves, or polar curves to Cartesian curves. So from this triangle itself, once again, by dividing these both the equations, we obtain y by x equals to r sin theta by r cos theta when we divide these two equations. So y by x as it is, r get cancelled, sin by cos is tan theta. So tan theta is equals to y by x. Theta is equals to tan inverse of y by x. So theta is equals to tan inverse of y by x. Now the applications of polar curves. So here, as we have some applications of these polar curves. So what are those applications? The first one is to know the intensity of light, to know the intensity of light emitted in different direction. Polar curves are required to calculate number of lamps in illumination design. It indicates the coverage of light, which helps helps in determining lightning scheme. So this is the end of the concept polar curves. Thank you.